Welcome back to the deep dive. I really hope you're sitting down for this one.
Yeah, and maybe have a very strong cup of coffee in hand, too.
Honestly, maybe 2 cups. Because today, we are going to break your brain a little bit. And I mean that in the absolute best possible way.
Oh, absolutely.
We are looking at a stack of research today that challenges, and I mean, it really goes after one of the foundational pillars of modern physics.
It is a fascinating rabbit hole,
Yeah.
to say the least. We are looking at a geometric framework called the Xeonod chat model.
Right.
And this draws heavily on concepts from a researcher named Akifumi Higashi. The central idea here is something called the dense clock field.
The dense clock field,
Mhm.
which, it sounds like something straight out of a hard sci-fi novel.
It does.
But the premise is actually incredibly grounded in geometry. The core question we're looking at is terrifyingly simple. What if the fundamental way we understand time, light, and motion is based on a mathematical illusion? Like, what if Einstein's special relativity, specifically that idea that light reaches two ends of a moving train at the exact same time, is just, well, wrong?
Or to be maybe a bit more precise, what if it's a fabricated truth?
Elaborate on that.
Well, what if it is a map that our minds create, but it doesn't actually represent what's physically happening in the electromagnetic field? The sources we have today are this wild mix of dialogues, mathematical derivations, and these really vivid geometric visualizations.
Yeah, lots of trains and spheres.
Exactly, and a concept I absolutely love called postal light rays.
Postal light rays. We are definitely going to unpack that because it paints such a brilliant picture. But the overarching mission for this deep dive is to see how this model completely separates physical reality, what the atoms in the physical light are actually doing, from perceived reality.
Which is basically this bubble of information we all live inside.
Right. And if this model actually holds up, if the math checks out, it suggests that special relativity might be a finished theory, as in done, over.
It suggests that relativity is just a user interface. It's not the actual operating system of the universe.
That's a great way to put it.
And we might have been mistaking the icon on the screen for the actual program for, well, about 100 years now.
Okay, let's unpack this. And to do that, we really have to start with the classic physics example, because you literally cannot do relativity without a train.
No, it's basically illegal in physics.
Exactly. So set this up for us.
Okay, so I want you to visualize a train. But this isn't a normal commuter train. This train is moving at a very specific, very high speed, 0.8 c.
So 80% the speed of light.
Yes.
So it is absolutely hauling, obviously almost physically impossible for a real train. But for the sake of the thought experiment, we are flying.
Exactly. Now imagine you are on this train. You are standing in the middle, or maybe at the back, it doesn't matter. You have a ball.
And in this model, the ball represents a photon of light, right?
Correct. You throw the ball from the back of the train to the front. It hits the front wall, and then it bounces off and comes right back to the rear.
Okay, simple enough. I throw a ball, it hits the front, it comes back. But the train is moving at 80% light speed. So if I'm standing on the ground outside watching this happen, the speeds look very different.
Yes. And this is where the math gets really simple, but genuinely shocking.
Yeah.
Let's say the ball moves at speed 1 relative to the track. That represents the speed of light.
Got it.
When the ball is thrown forward, it's actively chasing the front of the train. But the train is running away from it at a speed of 0.8.
So it's a chase scene.
It is a chase scene. The relative speed, the actual speed at which the ball physically catches up to the front wall, is 1 minus 0.8, which is 0.2.
So it's barely creeping up on the front of the train. It's seriously struggling against the forward motion.
Precisely. It's a massive struggle. But now consider the return trip. The ball bounces off the front wall and heads back toward the rear. But the rear of the train is rushing toward the ball at 0.8.
So they are basically slamming into each other.
Right. So the relative speed for the return trip is 1 plus 0.8. That's 1.8.
So on the way back, it absolutely zooms. It's nearly instantaneous compared to the first leg.
It zooms.
Yeah.
Now, here is the big aha moment from the source material. If you look at the time it takes, the forward trip is slow, relative speed of 0.2.
Yeah.
The return trip is fast, relative speed of 1.8. If you divide 1.8 by 0.2, what do you get?
You get 9.
9. The forward trip physically takes 9 times longer than the return trip.
Whoa. Wait, let me just pause you there. Because usually when we hear about relativity from, standard textbooks, we hear all about simultaneity.
Yes.
Einstein says that if I am on the train, everything looks perfectly normal to me. I shouldn't see the light struggling at all. I definitely shouldn't experience a fast direction and a slow direction.
And that is exactly where the Zinod-Chat model drives a huge wedge into standard theory. Standard physics says, because you don't feel it, it isn't happening.
Right.
But this model says, no, it is happening physically. In the electromagnetic field, what the sources call the contact plane or the real world, there is a massive 9-to-1 asymmetry. It is not subtle.
So the light is physically fighting the wind of the train's motion.
Exactly. The outbound trip is stretching through what Higashi calls a dense clock field. It's physically harder and takes longer for the light to catch up to the front of the train. Space itself, or the time it takes to cross it, acts denser in that forward direction.
And the sources relate this to Bondi's K-calculus too, right?
They do. In physics, this 9-to-1 ratio aligns perfectly with the K-factor. But here, instead of just being an abstract math trick, it's treated as a hard geometric reality of the train moving on a track. The track acts as an anchor of events.
Okay, but if that's actually true, why don't I notice it? If I'm on the train, I don't feel like the light is taking 9 times longer to go forward. My flashlight beam doesn't look like it's crawling.
And that is the million-dollar question. If physical reality is this messy 9-to-1 ratio, why does our human perception feel like a perfect 1-to-1 balance?
Exactly.
To answer that, we have to completely leave the train track and enter the sphere.
The sphere. This is where the geometry gets really trippy.
It really does.
The sources talk about shifting from a flat XY plane, which represents the real physical world, to something called a sphere of recognition.
Right. Think of it like this. There are essentially two distinct worlds. First, you have the contact plane. You can also call it the tangent plane.
Yeah.
This is where your physical body is. This is where the atoms are. This is where the electromagnetic field actually exists. In this place, that 9-to-1 ratio is real. The asymmetry is absolutely real.
So that's the physical stuff, the messy, drag-heavy stuff.
But then you have the sphere. This is the observer's world. This is you. The source describes the observer not as a flesh and blood body, but as a point of consciousness trapped in the dead center of a sphere.
Okay.
And the surface of this sphere is like a screen or a window.
And the radius of the sphere, the distance from the center to the screen, that represents time, right?
Exactly. The radius represents time depth or pastness. Things that are further away physically take longer to reach us, so they're deeper in the past on the surface of your sphere.
The source material used this phrase that honestly gave me chills. It described the observer as having a half-out-of-body experience.
It's such a powerful image. The idea is that your physical body is down there on the flat plane, moving at 80% light speed, dealing with all that wind and drag and that huge 9-to-1 delay.
Right.
But your mind, mathematician inside you, is locked up high at the center of this sphere of recognition.
Right.
You are essentially disembodied. You don't feel the wind. You only see what eventually hits the surface of your sphere.
So we are basically these transcendent mathematicians locked inside a bubble, just looking at screens, trying to figure out what our bodies are actually doing down on the tracks.
That is exactly the premise.
Yeah.
And this brings us to the actual mechanism of how we get that information on the screen. This is my absolute favorite term from the whole stack. Postal light rays.
Postal light rays. It sounds like some kind of cosmic mail service.
It really does.
So how is a postal ray different from just regular light?
There is a huge difference. Physical light moves in the real electromagnetic field. It gets pushed around. It has to chase the train. It deals with that messy 9-to-1 struggle.
Yeah.
But postal light rays represent information.
Okay. So physical light is the actual event itself taking place. Postal rays are just the news report about the event being mailed to you.
Precisely. Think of them as discrete packages of data. A postal ray travels from the physical plane where the messy event actually happened up towards your sphere. But here is the catch.
What's the catch?
You, the observer sitting at the center, you don't see the ray while it's traveling. You don't see any of the struggle.
I only see it when it finally hits my screen.
Exactly. You only see the specific postal rays that manage to hit the surface of your sphere, the window. And here is the absolute most crucial rule of the sphere.
Okay, lay it on me.
Once those rays hit the window, the source says they travel straight to the center at a perfect constant speed. That constant speed isn't a physical law of the outside universe. It's an internal protocol of your mind.
Oh, wow. So light speed being constant, that whole foundation of modern physics, that's not about the outside world at all. That's just the speed at which my brain processes the incoming mail.
In this model, yes. It's the internal processing speed of your sphere. The mathematician at the center assumes the mail arrives at a constant speed because that's simply how the internal system is built.
Right.
It acts as if it has total knowledge of the universe, but really it's just receiving these very specific filtered data packets that happen to hit the window.
So going back to our train example, the light physically takes 9 times longer to go forward, but by the time that information becomes a postal ray, hits my sphere and gets processed, my brain just fixes it.
Fixes is one word for it. Fabricates is probably a better one.
Fabricates. Wow.
The sphere geometry is literally set up in such a way that it hides the delay entirely. It mathematically cancels out that 9-to-1 asymmetry.
Ow.
It takes the dense time from the forward trip and compresses it so that by the time the data actually reaches your center, the outbound and inbound trips look completely identical to you.
That is incredibly sneaky. It's basically like noise-canceling headphones for reality.
It's incredibly efficient.
Yeah.
And this concept actually explains one of the biggest, most famous puzzles in physics history, the Michelson-Morley experiment.
Right, the famous experiment that tried to detect the ether. This was back in the late 1800s. They spun this massive device, an interferometer, expecting to see light patterns change as the Earth moved through space. They thought, we are moving through space, so the light should definitely be affected by the headwind. But nothing happened. The light interference fringes stayed perfectly still.
And standard physics explains this away with length contraction. The idea that the physical arm of the device literally shrinks in the exact direction of motion just enough to perfectly hide the effect.
Which always sounded a bit convenient.
Exactly. But the Zion-to-Chat model offers a totally different explanation.
It says it's not just the physical metal shrinking, it's about how the postal rays arrive at the sphere.
Yes. When you rotate that interferometer down on the physical plane, the time depth, the actual physical distance the light travels, really does change. The physical reality changes.
Right.
But because your perception is entirely based on this sphere geometry, those changes cancel out perfectly before they reach your mind.
So the sphere itself is literally the geometry of time.
Yes, and the source makes a really brilliant connection here to James Bradley. He was an astronomer back in the 1700s who discovered stellar aberration.
Which is basically why stars look like they are slightly shifted in the sky because the Earth is moving.
Exactly.
Like how rain looks like it's coming at you sideways when you're driving fast down the highway.
Right. Perfect analogy.
Yeah.
Now, typically we just think of that as a simple tilt. But this model calls it a rotational slide on the surface of the sphere.
A rotational slide. I mean, that sounds like a dance move.
It does. But imagine the window on your sphere physically shifting. As your body moves through the EM field, the postal rays hit the sphere's surface at a slightly different spot than where they started physically.
Okay.
They literally bend or refract at the shell of the sphere before going straight to the center.
So the angle I think I see isn't the real angle at all.
No. The angle change is what we perceive as motion. The source says this refraction at the window is the only reason we even think we are moving. We are constantly reconstructing our own motion based on skewed data.
That is wild.
The sphere effectively rotates the entire image of the universe to compensate for the physical delay.
This is really painting a picture of reality that has distinct layers. It's not just, stuff happens. It's stuff happens and then we process it and then we convince ourselves it was simple all along.
Yes.
And the notes actually break this down into 3 very specific layers of reality.
They do, and this hierarchy is absolutely crucial to understanding the whole theory. You have to know where you stand in the system. Layer 1 is the transcendent mathematician.
Which is basically the God's eye view.
Right. This is the ultimate perspective that sees the flat plane for what it is. It sees the train actually moving at 0.8 c. It sees the absolute truth that the light takes 9 times longer to go forward.
It sees the mess.
It sees the asymmetry. It sees all the mess.
But we aren't that mathematician. We can't just step outside the universe to look down at it.
No, we definitely cannot. We are mostly operating at layer 2, the recognition sphere, the user.
The user.
This layer has accumulated, say, 10,000 years of evolutionary data to build a functional map. It uses these incoming postal light rays to construct a clean, symmetrical hologram of reality.
And this layer 2 fundamentally assumes light speed is constant.
It has to. That's the foundational rule for drawing the map. It says, I receive this packet, therefore it must have traveled at speed c. It actively smooths over all the bumps. It creates a symmetrical world because, frankly, that is much easier to navigate.
But then there's layer 3, the body. And this is the one that really got me when I was reading through this.
Layer 3, the body. The source brilliantly calls this the gambler,
I love that so much. Why the gambler?
because the physical body lives in the absolute now. It doesn't have the luxury of the finished map. It doesn't have time to wait for the postal ray to hit the sphere, travel to the center, and get neatly processed by the mathematician.
It's down in the trenches.
It is in the trenches. It's moving at 80% light speed, dodging real atoms, dealing with actual physical drag.
Yeah.
It only gets a tiny fraction of postal rays right this exact instant.
Right.
It has to figure out where it's going based on just a few photons hitting its eyes right now.
So it's just guessing.
It's using Bayesian inference.
Yeah.
Statistical guessing based on prior probabilities. The body says, okay, based on the last few seconds of memory and the current refracted angle of this specific light ray, I bet I'm moving that way.
Wow.
It doesn't know. It literally bets.
That is terrifying and beautiful at the same time. My perception of now, that deep feeling of being present in the moment, is really just a bet my body is making based on old mail.
Precisely. You are betting your everyday survival on data that is technically already from the past. You're just surfing the probability wave.
This directly leads us to the big confrontation in these sources. And just to remind you listening, we are just presenting what the research says here, but the source material explicitly aims to terminate special relativity. That is a direct quote. Terminate.
It is a remarkably bold claim. The whole argument is that Einstein's theory is based entirely on one specific axiom. That light reaches both ends of the moving train simultaneously. Einstein said, well, if I am on the train, it looks simultaneous to me, so that's a perfectly valid reference frame. It's real.
But our transcendent mathematician view, that layer one perspective, says that's literally impossible.
Correct. In the real EM field, that actual line of atoms moving at 0.8 C, the physical light cannot reach both ends at the same time. The rear is actively rushing toward the light. The front is running away. You cannot cheat the physical distance.
So simultaneity
It is a complete fabrication. It's a trick of layer two, the sphere of recognition. It is just a mathematical shortcut we use to make sense of the delayed postal rays.
unbelievable.
The source states that once you separate the real world from the information world, all the paradoxes of relativity just disappear.
So you don't need time dilation at all. You don't need the whole twin paradox where one twin goes to space and comes back physically younger.
You don't need them as physical realities. You only need them as rules for your information map. You are left with a purely deterministic geometric reality where now is fundamentally distinct from seen. The physical world is messy and highly asymmetrical, but the information world we build is smooth and symmetrical. Einstein described the information world perfectly, but he mistook it for the physical world.
That is a massive distinction. It's like confusing the GPS on your phone with the actual road you're driving on.
Exactly.
The GPS says the road is perfectly straight and you are moving at a constant speed, but actually the car is hitting massive potholes and sliding sideways in the mud.
And maybe driving sideways entirely.
Right. If you only looked at the GPS screen, you'd never know you were in the mud. So what does this all mean for us? We've traveled from a train moving at 80% light speed, found out the physical light takes 9 times longer to go forward, and then realized our brains are basically just spheres trapping us in a constant hologram of old mail.
It definitely sounds bleak when you summarize it like that, but I actually find it incredibly empowering. It suggests that the rigid laws of physics we constantly struggle with might just be the internal rules of our own processing system. We are mathematical users. We actively create a consistent reality out of incredibly skewed, delayed data.
It really redefines what it means to be an observer in the universe. We aren't just passive cameras taking it all in. We are active creators of this symmetry. We are fixing the universe in real time just to understand it.
We are constantly smoothing out the universe's rough edges just so we can function within it.
It really makes you wonder if our perception of now, that rock-solid feeling of being present, is just a Bayesian bet based on delayed postal rays. Do we ever actually experience the present moment?
That's exactly the thought that keeps me up at night. Are we ever truly living in the present? Or are we always just surfing the surface of the past, perpetually waiting for the mail to arrive?
Surfing the surface of the past? And if we take that one step further, something for you listening to mull over today. If our body is just betting on delayed mail, is our sense of making a choice right now just another illusion generated by the sphere to make the map work? Are our choices as fabricated as the simultaneity on that train?
That is a whole other rabbit hole right there.
I think I'm going to need a minute to process that one myself. We will leave you with that thought. Thanks for diving deep with us.
See you next time.